Alright, so you guys have your paper plate. Kind of flatten it out. Again, your pens will write better on the non-glossy side. So like the part you're supposed to eat your pizza on, that's a little bit more glossy so it doesn't get grease on it. So we're actually going to use the other side. Alright, the first thing we're going to do is we're going to fold it. So how many degrees do I have, class? 360. How many radians? 2 pi. Now if I fold it in half, class, how many degrees? 180. Radians? 5. Now if I fold it in half again, class, how many degrees? 90. Radians?
Pi over 2.
Pi over 2. So essentially what you have here is when you open it up, non-glossy side, you have the quadrantal angles. Use a light color to draw your axes. Class, what axis? This is the y-axis. And this one? X. Class, where the x and the y-axis meet, this point is called the origin, which has the order pair. And if I go around on this smaller circle where there's no pleated or ribbed plate, now if I take a ray and put its endpoint at the origin, this is in which position, class? Let's write that. If I draw an initial side of an angle, this is called standard position. Class, if you have a point on the center and it extends to one point on the circle, this is called a radius. And our radius in the unit circle is 1. That's why they call it the unit circle, or you can call it 1 unit. This is what you and your partner will need to do. You will need to go around the unit circle and label the quadrantal angles. What are you labeling? Quadrantal. You're labeling the order pairs. You're labeling the angles in degrees and radians. Alright. Girls, go ahead and tell me the order pairs. Girls up over here. And over here. Alright, order pairs are labeled what? What? X and Y. Alright, now this is where your colors are beneficial. I'm going to go around in degrees. Boys, go around in degrees. 180. I'm going to use another color now, and we're going to go through radians. Class? I like to write pi there because 0 times anything is 0, but I want you to recognize that it's radians. Over here. Pi over 2. So there we have the quadrantal angles. And remember, in your quadrantal angle, because the radius is 1, going around your radius will always be 1. Alright, let's now expand to the 45s. So let's go back and fold in ours. Class, how many degrees? How many?
90.
So if I take an angle bisector, I get what? 45. Alright, so if I open it up, now it's okay if you make a mistake, but the fold, like my fold, doesn't even go in a straight line, but it gives us an idea where it should be. Now at this time I want to show you separately, on a more messier way, how to label our 45s. And then together, afterwards, we'll count going around the 45s. So everyone put your pencils down, just watch. It's a counting technique I just took from the internet. It was actually a trig student from 60 years ago that figured it out. So I just want to show you the 45s. So there are the 90s and here are the 45s. Don't copy it, you're just watching, that's more important. And when we count the 45-degree angles in radians, well, let's just go around in 45s, okay? Degrees, ready, set, go.
0.
0.
90. 270.
Okay. Here's the counting technique for the 45s. In radians, what is 45 degrees? Okay, it's pi over 4. But I'm going to write a 1 here. Just watch. And this is how I'm going to count the 45s from standard position. 0, pi over 4. 1, pi over 4. 2, pi over 4. What's the next one?
3, pi over 4.
Keep going.
4, pi over 4. 5, pi over 5. 6, pi over 4. 7, pi over 4. 8, pi over 4.
Okay. Now I didn't want you to copy this on your unit circle because it's going to get messier. I'm just simplifying it. And you should start to see where some of those connections are. Class, if you reduce 0 pi over 4, what do you get?
0 pi.
You just get 0 or 0 pi. We're going to keep this one. Can I reduce that one?
Yes.
Pi over 2. Over here?
No.
So keep it. Over here?
Yeah.
That reduces to what?
Pi.
Over here?
No.
Here. Okay, so what I just did here is I counted the 45, 45 90s. And here's a little trick. It starts with a 4. That was my denominator going all the way around. So as you're doing this on the unit circle, you're essentially thinking like this. You're going to do the reducing as we go around, but you don't need to write all these other equivalent fractions. See that together? I started in degrees in green, and I'm going to continue doing the same thing. Let's count the 45s in degrees, class. Count. 0, 45, 90. Oh, let's pause, sorry. Let's draw our line. Now, I'm going to use a very bright color, and you're trying to use the creases. It may not be exact, mine are not exact. And I'm actually going to go past that little circle that we actually drew. And I used a bright color such as pink because I want to eventually to skip them when we count the 30s. Let's try that again, counting the 45 degrees. Ready, set, go. 0, 45, 90, 135, 180, 225, 270, 315, and 360. Now I'm going to go back to the color I had used before for radians. I have 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. That was counting the 45s. Alright, let's go ahead and do the 30, 60, 90s. I just want you to watch. This diagram is meant to be a little bit messier. This diagram is meant to be a little bit messier, so when we eventually put it on our unit circle, it's cleaner. I just want to show you where it comes from. I'm going to count by 30 degrees, and if you notice, between the quadrantals, which is a black dot, there are essentially 3 dots in the unit circle. But in the middle one, I've decided to skip or put in red as an X because class, those represent the 45s. So as I go around, I'm going to skip the 45s. Class, this is how much in degrees? 0. 30. 60. 90. Losing steam. Okay, so that's how you count with the degrees. Now I'm going to show you how to count by the radians. The radians, if you memorized before, the first one, 30 degrees is what? It's pi over 6. So I'm going to count as my denominator of 6. Okay? 0 pi over 6. 1 pi over 6. This one. 2 pi over 6. 3 pi over 6. 4. Here. 5 pi over 6. 6 pi over 6. 7 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 So I counted with a denominator of 6, and now I'm going to go back and reduce. 0 pi over 6 is just 0 pi. We'll keep this one. This one reduces to this one, pi over 2. Keep it. 4 pi over 2. 3 pi over 2. 5 pi over 2. And this one? 2 pi. So I wanted to show you this kind of a little bit more messier, how I got the 30, 60, 90. So when we actually go back to our unit circle, now between the quadrantals, you can go ahead and have 3 dots. And let's actually fold it. So class, let's zoom out. Class, how many degrees? How many degrees? How many degrees? Okay, stop here. Don't fold anything. Okay? Just listen and watch. last time we bisected the 90s to get a 45, yes?
Yeah.
But if I fold that, that'll be a what? 22 and a half. So I have to fold the 90 into thirds. 3 30s. So look what I'm going to do. Fold it into a third. You're going to estimate. It's okay if you're wrong. It is going to be kind of hard. You can fold the other way if you want to. It's a fraction lesson, right? 1, 2, 3. So again, I'm just going this way. This way. And remember, it's just to get an idea where the crease might be. Okay, let's open it up. Alright, now I'm going to go ahead and use my ruler. Now if you look at my crease here, I have 0 to 45. And I have this one right here. And if you kind of follow the line, it'll kind of make sense if I draw this line now. Do your best. And here's the reason why I'm drawing this blue line, or my other one, in this direction. Remember, those lines should be doing your best to go through the origin. I should extend that. Now, pay attention. Notice how this is really a 30-degree angle. Does that make sense? So on this side, on the bow tie, this reference angle is also 30. Or if you went down here, that's also a 30. Or down here, that's also a 30. Now I'm going to go ahead and go through and draw the 60s. Now, how do you know if it's a 30 or a 60? Well, you can follow your crease. Or, if you think about it, it's the third dot from the quadrantal. 1, so I need one there. Or even in this direction. Okay, if you don't have those specific colors, just do this. Between the quadrantals, go ahead and draw your 3 dots. Alright, we're going to do the same thing as we did in the notes. We're going to count by 30s and we're going to skip the 45s. Class, this is how many degrees?
0.
Okay, use color pen. We count degrees in green. So 0. How much is this one?
30.
30. Skip. 60. 90. How much? 30 more. 120. Skip. 150. 180. 210. Skip the 45. Skip the pink. 225. What do I get here? 240. 270. 300. And then skip. And you get 330. Then 360. Alright. Now I'm going to go around and count the 30s using my method of denominator of 6 for radians. And as I think out loud, I need to reduce it as I write it down. 0 pi over 6. This one, pi over 6. Skip. 2 pi over 6, which is what? Pi over 3. 3 pi over 6. 4 pi over 6, which is?
Pi over 3.
Skip. 5 pi over 6. 6 pi over 6. 7 pi over 6. Skip 8 pi over 6, which is 4 pi over 3. 9 pi over 6. 10 pi over 6, which is 5 pi over 3. Skip 11 pi over 6. And 12 pi over 6, which is 2 pi. That is now counting the radians using a denominator of 6. Alright, now I'm going to show you guys how the order pairs are associated with these angles. I have another counting technique, and I'm just going to use my finger to kind of show you the direction I'm going to go. I'm going to go from 0 to 4, and then count down 4 to 0. And they're going to count from 4 to 0, and then 0 to 4. Watch as I do it. 0, 1, 2, 3, 4, 3, 2, 1, 0, 4, 3, 2, 1, 0, 1, 2, 3, 4. I'm going to put all of these under a denominator of 2. I'm going to put all of them in a radical. Class, what's the square root of 1? I'm not going to put a square root on it because the square root of 1 is just 1. Oh, no, they now have a busy. 2. Now, think about this. Class, what's the square root of 0? 0 divided by 2 is 0. The square root of 4? 2 divided by 2 is 1. This counting technique, 0, 1, 2, 3, 4, 4, 3, 2, 1, 0, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4 was actually found by a trig pre-calculus student 60 years ago. I just found it on the internet, and I liked it because it's just the idea of counting. Now, some things that we know about our quadrants. Quadrant 1, this one is 2, 3, 4, is that we know in quadrant 1, all students take calculus. So that means in this quadrant here, when you pick an ordered pair, such as radical 3 over 2 1/2, I would have to go right or positive on the x values, then negative on the y values. So that means all of my y values are negative here. Now it's symmetrical. You really only need to understand this part. But I'll show you my counting technique for the other quadrants. And at the end of the day, you might say, Mr. Ring, this is too difficult, and you can keep drawing your triangles, but you'll notice that this actually goes a little bit faster. So I'm going to do the same thing. You can count with me. I'm starting here at 0, and we're going to go in this direction, and then we're going to count back up. 0.
1, 2, 3, 4.
And down.
3, 2, 1, 0. 1,
4.
3, 2, 1, 0.
Let's write 0.
1,
1, 2, 3, 4. Class, all of the denominators are what? And how about our numerator? Square roots. In quadrant 2, which coordinate is positive, which one is negative? Sine is positive and cosecant, but how about in terms of x and y? If you thought of an ordered pair. Going left, that means the x values are negative. In quadrant 3, which coordinate is negative? They're both. X's and y's are both negative. How is this unit circle actually related to what we've been doing? Let's just say I want to find sine of 60 degrees. Old school, sine of 60 degrees, you would draw a 60-degree angle, and across the 60 was always what? Radical 3. Across the 30 was always 1, and across the 90-degree angle was 2, and then sine was y over r. So our answer was radical 3 over 2. Yes? That's a lot of work to draw the triangle. I have this. I just have to put my finger at 60 degrees. Put your finger at 60 degrees. And if you think about it, cosine is x over r, and r is equal to 1, so instead of saying x over r, you can say x over 1, or just x. Therefore, the first order pair is cosine. Everyone say that.
Cosine.
And the second order pair is going to be sine. How will you remember that? My hint is alphabetical. The order pairs go alphabetical, x, y. The trig functions go alphabetical, cosine, sine. So how do I use this unit circle? I go to sine, I go to 60 degrees, and I'm looking for the second order pair. My answer is radical 3 over 2. Didn't have to draw a triangle. Is that easy? Let's try another one. Let's try a hard one. Let's try tangent of 5 pi over 4. Back in the days, you would have to draw your triangle, figure out which quadrant. This is 4 pi over 4 over here, so it has to be a little bit more. So it's going to be over here somewhere, bow tie problem, right? Closest x-axis, 90 degrees. Then you have to find the reference angle up. This is 4, that's 5, so this would have to be pi over 4. That's a 45-degree angle. Then I have over here across this, so this would be y equals -1, x equals -1, and r is equal to radical 2. Tangent is y over x, -1 divided by -1, and I get 1. Lots of work, right? Now, with tangent of 5 pi over 4, count with the 45s, 1 pi over 4. 2, 3, 4, 5 pi over 4. Tangent, y over x. Negative radical 2 over negative radical 2. Which is just what? 1. The unit circle allows you to move faster. Now, some students ask me, Mr. Ring, do I have to use this unit circle? You do not. But this is kind of like a multiplication table. Some of you will be able to memorize it and visualize it, so you don't have to keep drawing out the triangles. If I had a preference of one for you to know, I would want you to know how to draw out the triangles. Does it take a little bit more work? Yeah, it does. Draw the triangle, find the reference angle. But I wouldn't want you just to memorize this and not see the connection to here. Does that make sense? I'd rather you have both. Class, what quadrant is 7 pi over 4?
4.
So if I'm thinking to myself, 0, 1, 2, 3, 4, 5, 6, 7 pi over 4. I'm down here. Now ask me for cosine. Cosine is the first order pair. Cosine is positive. Your answer is radical 2 over 2. Raise your hand if you got that. Let's use sine of 135. Put your pencil on 135. Partner B, whisper to partner A. What is sine of 135? $135 is in quadrant 2. I need sine. Sine goes, remember, cosine, sine. So it is the second one. Your answer is positive radical 2 over 2. Now, this leads us to a hint. Every 45-degree angle, your answer is going to be what? Something like radical 2 over 2. That's something we've done with the triangles already, right? Alright, so if I'm looking at this problem here, class, how can I make this a coterminal angle? What would I have to do? Add or subtract a whole circle. Well, a whole circle is 6 pi over 3, which gives us what, class? Sine of 5 pi over 3. If I go here and locate 5 pi over 3, I'm looking for sine, which is first or second? Your answer is negative radical 3 over 2. Raise your hand if you got that. Tangent of pi over 6? Uh-oh. I don't have it because it's cosine over sine. That means I'm going to have to use y over x. Well, my x value is radical 3 and my y value is 1. Remember, these are the r values. So I have 1 over radical 3, which means I would have to rationalize radical 3 over 3. Raise your hand if you got that.